Topic 1.4, estimating square roots. Sometimes finding a square root is not so easy. You may need to estimate if there is no calculator handy. You can estimate a square root by using benchmark squares that you do know. Use these as benchmarks and then estimate the square root. You can do this using squares or a number line. Let's have a look at some examples. Let's say that we're asked what the square root of the number 13 is, and we don't happen to have a calculator handy to help us. So we need some way to estimate. And one way to do that is to use what we call benchmarks, which are simply numbers that we do know. Okay, so we can start by listing the square numbers that we do know. 1 squared is equal to 1. 2 squared is equal to 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. Well, let's go up to 10. 9 squared is 81. And 10 squared is 100. Okay, so we know that this column here to the right, these are all square numbers, and these numbers over here that are being squared, these would all be the square roots. These are numbers that we know, or that we can list and refer to. Okay, so the square root of 13, remember that when you're given a question like this, the value that appears here in the square root symbol is actually the area. It's the square number. So this 13 would actually be the square here. So let's take a look in our square column and see where the number 13 would fit in. It actually fits in between 9 and 16. 13 is in here. Okay? Now, we can say then that the square root of the number 13, if we know that the square root of 16 is 4 and the square root of 9 is 3, we can say that the square root of 13 would be between 3 and 4. So it's probably somewhere around 3.5. And we can get a little bit closer than that by using a number line. So we'll use a number line. Say this is 3. It's going to be 3.5, and this is going to be 4. We know the square root of 9 is 3. The square root of 16 is 4. Okay? And then we take a look at the number 13 and we figure out which number is it closer to. Is it closer to 9 or is it closer to 16? Well, 13 is 3 less than 16 and it's 4 more than the number 9. So it's actually slightly closer to 16 than it is 9, right? By 1. So the square root of 13 would probably be somewhere around here. All right, so we were estimating now, okay? It's a little bit more than 3.5, so, you know, we can estimate it as, let's say, 3.55. That would be a good estimate. We can follow that same process for B and C. So if you want to find the square root of the number 5, you would want to determine that the number 5 is between 4 and 9. Okay? We know that the square root of 4 is 2. We know that the square root of 9 is 3. So we know that the square root of 5 should be between the number 2 and the number 3. Now it's really beneficial to draw it out like this on a number line because you can get very, very close to the true square root by doing that. So let's try it. Let's put our number line here. We know that the square root of 4 is 2. Okay, we know the square root of 9 is 3. This can be 2.5. We know that the number 5 is 1 away from the number 4. It's 1 more than 4. And the number 5 is 4 less than 9. So we know that it's going to be closer to 2 than it is 3. It's going to be approximately somewhere around here. All right? This would be the square root of 5. So if we were to put a value on that, again, this is just an estimate, so that would be approximately 2 point, let's say, 1 or 2.15 even. Okay, that would be a good estimate. Either of those would be good. You can follow the same procedure for C, the square root of 62. We know that the square root of 49 is 7, and we know that the square root of 64 is 8. Okay, so we can use these two benchmarks to estimate the square root of 62. Now the number 62 is closer to 64 substantially than it is to the number 49. So we know that our estimate should also be closer to the number 8. So 7.8, 7.9, somewhere in there, either of those would be good estimates. Okay, so we could say 7.9. Just make sure that you also show how you know. So we've estimated that it's 7.9 approximately, and we can prove that by saying something to this effect. Because the square root of 64 is equal to 8, the square root of 49 is equal to 7, and 62 is close to 64. Okay? Then we've illustrated here that we've used benchmarks and that we understand that the number 62 is actually closer to 64. That explains our estimate, and that's great.